But it's actually nice if I just pause, no pun intended there, to, oh boy, Don's going to be so mad that because like I'm going to like unleash all my puns. And
oh, I love puns. We're in trouble.
Inject, define, APK, lifecycle and design, null check. Inject, define, APK, lifecycle and design, null check. Inject, define, APK, lifecycle and design, null check. Inject, define, APK, lifecycle and design. It's time.
From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm DonnFelker.
And I'm Kaushik Gopal.
Welcome to the show.
Today on Fragmented, Kaushik talks with Kristin Marsicano about the Android activity lifecycle. The lifecycle is something that's all very near and dear to our hearts as Android developers, for better or for worse. It really all depends on how you look at it. Unfortunately, today I'm unable to join the show, but Kaushik and Kristin really dive deep into the details surrounding the lifecycle, and I hope you enjoy it. Kaushik, take it away.
Before we begin, I just want to take a quick moment and thank our sponsor for this show. I'm super happy because, again, it's one of my favorite sponsors, Rollbar. Okay, so in the past segments, I've talked about RQL, which is their Rollbar query language, how you can use curl commands to replay requests, even using Rollbar for assertions, and all kinds of tips and tricks. I realized, though, that I've actually never told you about a very important feature, rather, that they have, which is like all the kinds of platform support and external integrations that they have. For example, Rollbar is available on almost every major language and platform that you can think of. Android, iOS, Rails, Ember, Angular, Node.js, Django, and even PHP for those of you who remember what that language is. If you want to use them, there's almost no doubt that you can do that in the language or framework that you work with. They also have really cool integrations with a bunch of messaging and notification services. For example, Slack, HipChat, PagerDuty, and Datadog. The PagerDuty integration is like a lifesaver for me at Instacart. We can get certain Rollbar events to actually trigger PagerDuty notifications. So if we notice something bad happening on the clients and want our on-call engineers to know immediately, then well, with PagerDuty integration, it's totally possible to do that. This way, we can catch code errors or problems even before our users do. You can do a whole bunch of things thanks to their numerous integrations and pretty robust platform support. So give Rollbar a try today. Head on over to rollbar.com/fragmented. That's the special link they've given for Fragmented listeners. And with that link, you get their Bootstrap plan for free. Make sure to use that link because that way they'll also know that you came from our show. So thanks again for supporting today's show, Rollbar. All right, folks. So today I have the one, the only Kristin with me. Hey, Kristin.
Hello, how are you?
I am doing good, and I'm super excited to have you on the show. For the few listeners who haven't heard about you, could you give us like a quick intro into how you got into Android programming, what you find interesting about Android, and how you got started?
Yeah, sure thing. So it actually started way back in, I don't know, maybe 2009 or 2010. And I used to teach computer science classes at Georgia Tech. I did that for about 5 years. Mm-hmm. And I got to go to this thing at Google about App Inventor for Android. And it was a way for people who are not programmers to start making Android apps and to dive into computational thinking. And so through that, I got a grant to get, I think it was like 50 Android phones. I can't remember if it was a G1 or G2. And so I got all these phones and I was trying to figure out how to use them. And my class sizes were huge, so I didn't actually get to use them in my classes, but I ended up using the phones and sort of the experience I'd gotten to help start a mobile application developers club at Georgia Tech, which is kind of cool. It was a way for students to learn about mobile development, and we got started with Android. And so as a faculty advisor, I offered to teach a couple of lessons. And so, I got a book at the time. I think I got Hello Android.
Nice.
And believe it or not, the first little demo I did, it was like a silly, coin toss app. But I remember I was talking about the activity lifecycle. So, it's long been a favorite topic of mine. But anyway, from there, I got involved in Android, and it just so happened that I had a friend who was working at Big Nerd Ranch. And he told me all about it. And, they at the time were looking for Android instructors. And I was also, missing working on a team and doing app development. And so the timing worked out. They were looking for an instructor. I had teaching experience and some Android experience. So I came to Big Nerd Ranch, and I spent a lot of time studying the first edition of the Android book, but also I got right on a project. I was working on an application actually for a big cable company. So it was a lot of video streaming and complex stuff like that. So I just, dove right into Android, and I've been doing that ever since.
The Big Nerd Ranch is probably one of the best resources. And for folks who haven't read the book, so the book is Android Programming, right?
Yes, Android Programming, the Big Nerd Ranch Guide.
So we'll definitely add a link in the show notes to that book for those of the folks who are interested in reading the book. So you mentioned about activity lifecycle, and recently you gave, I think, a conference talk. Was it DroidCon NYC?
I gave, the activity lifecycle talk.
Oh, no, it was
360 and
It was a 360
yes. I gave a different talk at DroidCon, New York City.
Got it. A fantastic talk. I really enjoyed this talk. And so that's also one of the reasons both Don and I were super excited to talk to you about this. So we thought in today's episode, we'd maybe dive in, talk about like some of the quirks, like some of the common gotchas, like maybe some of the nuances and the details that go into the activity lifecycle. Alrighty. So typically, when you have an Android application, right, especially for Java developers, most people are used to instantiating stuff using constructors, right? But that's not the case, at least with Android, right? Specifically with activities and fragments, you can't really use a constructor. And that's where like all the lifecycle stuff comes in, right?
Yes, exactly. Yeah, that's one of the key things I try to always make clear when I'm teaching Android to somebody new is like, you're not the activity. It's super important. To your user, they really equate your activity with your app. It essentially represents a screen they're interacting with. But you don't get to create the instances, and instead those instances get created by the operating system depending upon what the user's doing. Maybe they've, if they've clicked the icon from the launcher, for example, that's going to issue a request to the operating system called an intent. And that intent is used to figure out what activity should be started, and ultimately the operating system creates an instance of that activity and starts it up.
When I first looked at your talk, right, I was like, oh, the activity lifecycle seems like simple enough, right? It's probably on create.
It's
on, and the thing is, if you work as an Android developer, like the on create, on resume, on pause, like these things are like things that just come naturally to you, right? But it's only after I saw your talk that I realized there's like so many small details that, honestly, if someone were to ask me and put me on the spot, I wouldn't have like recollected those, or I wouldn't even have known like some of these nuances. So those are like some of the things I'd really be excited to talk to you about. I want to step back before that, and let's talk about this concept of the activity manager, right? So what exactly is the activity manager? Because I don't necessarily recollect us directly accessing this. Like typically when you write an Android activity, you're not directly thinking about the activity manager, right? So what's the role of this thing in all of the lifecycle stuff?
So reality, I think of the activity manager as the one who's listening for these intents or these requests that are being fired. And it's the one routing them in a way, right? It's figuring out what activity should be started and kicking off that whole process.
Right. So it's basically this sort of background running thing that handles like all the, because you mentioned about the intents, right? And like the intent system is probably one of like the most powerful things that we have on Android, right?
It's awesome.
Yeah, it's pretty awesome. So let's maybe like walk through that exact process, right? So the activity manager listens for this intent, and then the intent fires, right? What happens like at that point, right? So at that point, like, does my app just fire up? How are the processes managed? Is for each intent, is there like a new app process? Like, what exactly happens there?
Oh, good question. In general, by default, every application is going to get one process. And so, if you're booting up your phone and your application, your particular app has never been started, there's no necessarily process for it. So let's say it's a fresh launch. The user clicks the icon, the intent fires. The activity manager, figure out what activity to start, and it will launch a new process for your app. And the activity that it's spun up, your launch activity, the instance of the activity will live in that app process. And then any other from there, let's say we launch a new activity by clicking a button or something on the existing activity. That new activity instance will also live in that same process.
Got it. Okay. So that app process is like dedicated towards the application that you write. So if I open up maybe, like the Google Maps app or like or Inbox or like the Gmail app, anytime any intent fires that launches this specific activity, it's all maintained in their independent processes.
Yes. Now it can get a little tricky if you start to think about scenarios where you launch an activity from another app. For instance, if I'm going to, let's say my app is to log office crimes, and in there I have a button to pick a contact, that will allow the user to launch their favorite contact picker app. That does spin another process, but there's a whole nother mechanism so that called a task that makes it seem to the user that it's one thing that they're doing. They can hit the back button to go back through their history, so on and so forth.
Got it. That makes sense. And this is the part that really sort of like made me feel, wow, I don't know anything about Android. And this is the activity states, right? So if someone were to ask me initially, like, what are the different activity states? I would have said probably on created, on started, on resumed, on paused. But that's like not true. Like there are very distinct activity states, right? Can you walk us through like these activity states? And I mean,
sure.
How did you find out about these activity states?
Well, a lot of it was in teaching. So Big Nerd Ranch has an Android bootcamp course. And we teach a lot of these fundamentals. So in teaching the class, that's really why I had to dig into these and understand the different states versus the callbacks and how they relate to what's actually going on.
Got it.
So yeah, I mean, don't feel bad about it. Even in the documentation, there's not always consensus on what these states are even called.
And these aren't necessarily explicit states in code, right? Like, for example, or I mean, maybe they are, but at least these are not necessarily things that we see. Like, we don't see activity state dot stopped or like what the different activity states are, right?
Right.
Got it.
Right. Yeah. In reality, as an Android developer, we're really interacting with the callbacks, which is why when you say, I thought of it as on created or on resumed, because when you're writing your code, that's what you're seeing. You're overriding these callback methods, but each of those methods are really like an edge, right? That move you between the states.
Makes sense.
And then your app can live in one of these states for some amount of time.
In one of your slides, and I'll make sure, because this is a little hard to like sort of explain purely in the audio medium, but I'll definitely make sure to add a link to one of your slides where you have this activity lifecycle, right? Now, typically most, like if you maybe Google activity lifecycle, like the one that usually comes up is the one that only talks about like these lifecycle callbacks that we just discussed, right? There's that standard one where people are basically saying how complicated Android is, and it's basically like a shaming sort of like a shaming / informative sort of flowchart that tells us like, and you're right, like it actually talks about like on create. So each box is like on create, on start, and that's how it moves. But you created this diagram where you show the different states and how these lifecycle callback transitions the app from that specific state, right? And I thought this was so clear. Like the minute I saw that, immediately the states made sense to me. So I'll definitely add a link to that in the show notes.
Oh, great.
But in the meanwhile, can you tell us what, we've been giving this build up about the activity states. So what exactly are these states? Can you tell us what the different states are?
Sure. Well, really what matters about the states is what they represent in relation to what the user's doing and what's going on in the system. So I really think of each, there's 4 states, non-existent, stopped, paused, and resumed, which I called running in my talk. But each of those really relate to whether or not there's an instance of the activity object in memory. whether or not the activity view is visible to the user, and then whether or not the activity is in the foreground. Because important thing to note is that only one activity can actually be the foreground activity at a time, meaning that is like the activity that the user is interacting with directly. So non-existent really represents the state where either, your app hasn't been launched yet or your particular activity hasn't been launched yet.
Okay, so this is basically like the cold launch, like where nothing has happened yet with respect to your application.
Yep.
Okay.
Either that or when the user pushes back off of your activity and then the activity gets completely destroyed. But ultimately means the activity instance is not in memory. So any state you had stashed in there, anything else is gone. And then obviously there's no view for the user to see, and it's certainly not in the foreground.
Okay, so the activity has no business being in... when the activity is basically checked out completely from the whole process, that's like non-existent, right? All right.
Yep. Exactly. Yep. And so stopped is sort of the next step up. And stopped represents that there is an instance of the activity in memory, but the user can't see it.
So when exactly do we transition into stop? Like what callback leads to that? Is there like a callback that leads to stop?
Yeah. So on create. So if you are in non-existent state, onCreate is called as your activity gets spinned up, for example, and moves you into onStop. So in that initial spinning up, the stop state, your activity is in that state for a very short amount of time. It's just passing through along the way.
Oh, got it. Okay. So that makes, because the first thing that seemed a little counterintuitive to me is the fact that like onCreate sort of like indicates like, okay, let's start something, right? But really onCreate like gets you to like this state called stopped, right?
Right. Yes.
So I think that might make sense to call that out to listeners. This is also very interesting that you mentioned that it's only like a sort of interim state. This is almost like a sort of logical state where the activity transitions from and to, right? Because I think what will make it interesting is like, because right now we're talking about how like we're transitioning forward into like the different states, but once we talk about transitioning backwards, like that's when like this makes
because stopped on spinning up the activity, it is like sort of a transient like quick pass through. Your activity could live in stop state for quite a while. An example of that might be as if the user's in your app and they press the home button.
Oh, okay.
The activity moves to stop state because it doesn't get removed from memory. Automatically anyway. And then, but it's not visible to the user.
Got it. And so again, there's like this nuance between if you hit the back button, that actually means a different thing from hitting the home button.
Yes.
Right? And like
it means very different.
Yeah. And we'll get to that because like, this is also like a great question to ask people who, if you want to like see if they've used like the Android system before, like this is a good question, I would think.
Absolutely. Yeah.
All right. So non-existent, I have onCreate. And now I'm stopped. I'm in this small interim phase called stop. What happens after this?
So from stopped, if we're spinning up, onStart is called, which moves us into the pause state. And the pause state is where, again, the instance of the activity is still in memory, but now the activity may be visible if only partially to the user. So in spinning up, it's going to be fully visible.
You mentioned some time back in passing that there's the foreground activity. So this is different. Like the foreground activity does not necessarily mean not visible. Actually, let me rephrase that. Just because it's visible, it doesn't necessarily mean it's on the foreground. Is that fair?
Exactly. Yes, that is fair. And up until recently, I mean, for something to be partially visible, that was kind of a rare thing. It may have been, if you had like a activity theme to be transparent or something, but for the most part, if it was paused and it was, it was visible but not in the foreground, the most times that happened, it would be when the activity was spinning up at launch.
Got it. And the reason you said for like up until recently is because of like, the new feature they added where you have like multi windows, right? Or like you have dual sort of like apps.
Yes, exactly.
Got it. Okay. So on start, let me think. And so we move into paused. You can see why it's getting a little tricky.
Yeah, it's definitely hard if you don't have visuals too.
Right.
So from pause state, we move through on resume to the resumed or running state. And so this is where your activity is the one that the user is interacting with. So the instance is in memory. It's obviously visible, and it's accepting the user input. It is in the foreground. It is the one activity that is like the highlight of the moment.
Got it. Okay. So this is its time to shine.
Exactly. That's how I like to phrase it.
All right. So like activity, if you have anything to do, like now's your chance, right?
Right. Exactly.
Perfect. Okay. So paused basically means it's visible on resume. So then we hit on resume, and that basically means the activity is like full blown in action.
Yes. And there's actually another diagram I made that, so to me, I really think of the life cycle as like 3 sub life cycles. You've got this notion of like the entire lifetime, or the instance life cycle, the instance lifetime. And so between the call to on create and on destroy, like anything in between that happens, there is an instance of your activity in memory.
Oh, okay. So the highlight. Oh, okay. So if you take this diagram and sort of like vertically sort of like position it, on create and on destroy essentially means like at that point there's an activity in your app process. Like that's what defines that specific state.
Exactly. I just dropped a diagram in there for you to see.
Oh, perfect. Okay. Oh, wow. Okay. So I just like opened up this link, and again, we'll make sure to add this like for listeners. Wow. This should be like the default diagram.
That's very kind. I love hearing you say that, because this diagram lived in my head for a very long time. So when I gave my first activity lifecycle presentation and people responded to it, it was a pretty awesome feeling. So I'm glad you like it.
Because I can see it, and like it's nice and color coded. And so because it's color coded, like I understand exactly like what's happening. So this is really good. Okay. So I'll definitely make sure to drop this in the show notes, and listeners, make sure you go and like, if anyone asks you about activity lifecycle, don't send them like the one that sort of like shames the activity lifecycle. Send them this one. This one's nice and very coherent. So.
Oh, thank you. But so yeah, there's the entire lifetime. There's the visible lifetime, which is the time in which your activity is visible to the user, and then there's the foreground lifetime, and that's when it's visible and it's in the foreground.
It also makes so much sense, because if you think of it with respect to what's happening with your views, if it's on, so as it gets into the paused state, you would presume that like, because there's a chance that your views have to be visible, like you can understand that that's why it's important at that point to have like your view in some state.
Exactly.
Right? Versus on resume, where it's like, finally, okay, this is where like things, like all the actions happen.
Yes. And that's so prior to multi-windowing, often, at least what I saw, was that the foreground lifetime, like between on resume and on pause, was when most apps would, do any kickoff, like in on resume, they would kick off any UI updates and then stop them in on pause, which wasn't that big of a deal, because before multi-windowing, it wasn't very common that you would have a paused activity that was very visible to the user for any length of time.
Oh, that makes so much more sense. So what you're basically saying is it didn't really matter as much if it was like right after on resume or like, on start, but there are like implications now is what you're saying.
Exactly. If you think about like one of my favorite examples to think about is video. If you are in on pause, pausing your video, because you're assuming that the view is going, that the user's not going to be watching the video anymore. In multi-windowing, that's a problem, because anytime you're in multi-window, only one of those activities is in the resume state and the other one is paused.
Oh, that's a fantastic example. Yeah. Your users would definitely be mad if you have multi-window and then the video is paused. They're like, what is the point of this thing?
Exactly. You're trying to like text and watch a video, and anytime you go to, write your text, the video pauses. I mean, that's kind of annoying. So
yeah, I know. I mean, how dare they, right?
I need to multitask.
I know. That's exactly how you be efficient, just keep doing everything. Oh boy. So here's my question though, right? I was thinking about the different lifecycle like states that we're usually, the lifecycle callbacks that we're used to. Where is on save instant state? And like, because there are like a couple of like lifecycle callbacks that are pretty important, especially because you talked about the activity recreation, right? Typically, like the way that it usually happens is that the most like recommended way, if you check the documentation, is that if you store your state on save instance state, and then like, you have like an on resume instance state. I don't recall the exact names, but where does that fit into like all of this, I guess? Can we like sort of like reason that out given our knowledge now of like these activity states versus like the actual callbacks?
Well, yeah. And first, just to be clear, so on saved instance state and on restore instance state, I don't know if those are technically lifecycle callbacks or not. It doesn't really matter. But I think the key thing that people often get tripped up on is that those are only called when an activity is being destroyed on the operating system's behalf. So, like if the user presses back, for instance, or if the activity gets finished because somewhere in your code you've called finish, on saved instance state is not going to get called.
Got it. Okay, that makes sense. Makes sense.
So on saved instance state is the operating system's mechanism to say like, hey, I'm destroying this activity for my own good, like because of a configuration change or because of a low memory situation. So on saved instance state is only going to get called in those scenarios.
Got it. That makes sense. Actually, now that I think about it, you're right. In fact, it might be easier to think of it independently, right? So like just think of it, okay, I need to save state. This is where I do it. And then if you keep like so for the listeners, if you keep what Kristin has said so far about like the visibility of the activity, like as long as you think of these as two independent problems, I think that actually might just like do it.
Right. Exactly.
So like on save instance state, okay, I need to make sure I save state there. And just like don't necessarily worry too much about where it fits. Because for the longest time, I always thought about because, when you actually write an activity class, you sort of override these methods, right? So I've always thought of these as like part of the same system. So I was like, oh, okay, first is on create and then there's like on start, then, on save instance state has to like slip in somewhere in between. And I've always thought of like this sort of linear model in my head. But actually, it makes more sense if I only keep like the lifecycle callbacks that you mentioned and then, treat that as an independent sort of mechanism. That will help me many a time. I don't have to worry about like copy pasting my activity code from somewhere else, which is again something that even I'm like very guilty of doing, right? Because I don't want to be thinking about these lifecycle callbacks. Just give me something to copy paste. I just want to start writing the actual code, right?
Yeah. I mean, like on saved instance state, it's called, like you said, it's called before on stop, but I think you're right. It's sort of like two separate things. The on saved instance state is a mechanism for, storing the transient data in a situation where the operating system is, consuming or killing your activity. Whereas the life cycle is really like in real time as your users interacting with it. It's sort of giving you an indication about whether or not they can see your activity, whether or not your activity is in the foreground, etc.
So, and again, if you talk about like the visibility thing that you mentioned, right? Well, it makes sense that it's going to it's no longer going to be visible. So you want to make sure that you save that state, right? So it almost makes sense that it would fit in.
Exactly.
There. All right. So I promise we'll try to like get through this life cycle because like there's so many interesting nuances to each of these things, right? So if we take the point, so the state called running, which is essentially where like, the activity is like, it's time to shine. Let's talk about now, because this is, so if I think about it as being like this mountain, right? Like this is where like you've reached the top, right? And at this point, it's time to start like descending. And so like there are multiple ways that you can descend from this mountain. And this is like, the source of like so many of our troubles, right? Like you could hit on pause, you could hit like, you could hit the back button, you could hit the home button. So can you like walk us through like, all the funny stuff that happens as you've reached the peak of the mountain?
Sure. So, you've reached the peak of the mountain and I guess unfortunately in Android, your activity probably doesn't get to stay there for very long. So one scenario where you might take one step back to pause is anytime a new activity is launched on top of you.
Oh, so, okay. So it's almost like you're being pushed out of the mountain.
Yeah. I'm sorry. And that would be stopped. My bad. That would move you all the way back to stopped. If you're no longer visible, you're being pushed down to stop.
Got it.
And the new activity on top of you is going up to the running, which I, by the way, I'm trying to call resumed state now because that's what it says in the documentation. But
No confusion there.
no, not at all.
Yeah, not at all. Let's just keep intermingling these terms. It'll figure itself out.
Right. But if another activity launches on top of your activity, then your activity is going to move to the stop state. Okay. And as soon as that activity is dismissed, you'll move back up to the resumed state. You'll be in the foreground.
Got it. And just so I understand, so you're saying the minute another activity launches in front of my existing activity, it would actually run through all the states, right? So it would go to on pause, it would reach the pause state, and then it would go to on stop, and then reach the stop state, right? It doesn't like jump to the stop state directly.
Yes, it goes through all of the callbacks. It doesn't get to jump over.
Got it. That makes sense.
Exactly.
So is there a way where I can bring it just to the pause state? So like without going all the way to the stop state, right? Under what situations would I be just paused? Right?
So multi-window mode is a good example of that one.
Got it.
So your view is fully visible, but you're not in the foreground. Another example of that would be, let's say I launch in my app, I click a button that launches another activity, but it's got a transparent background. So you could still see my activity behind it, which sounds weird, but another example is video. If you've got a video configuration screen, a lot of times you'll see the configuration screen launch above the video playback and the video is still playing. It's transparent. So those are two prime examples where it would sit in the pause state. I mean, other would be if you had an activity that popped on top that didn't take up the whole screen, so part of your activity could be seen behind it. It would be stuck in the pause state as well.
Got it. Okay. And sorry, if I hit the back button, right? As against the home button, it goes to stop. If I hit the home button, does it also go to stopped, or does it what's different then? Or is there anything different there?
Yeah, there is a difference. So
of course there is.
It's of course there is. I know.
Oh boy.
So hitting back is really the user's way of signifying I'm done with the activity. And so that tells the operating system it's safe to just destroy the activity.
Okay.
And so when the user hits back, your activity will go from whatever state it's in. Let's say it's in the foreground state. Through on pause, it'll be paused. Through on stop, it'll be stopped. And then through on destroy, and it would go into the non-existent state. So it would be completely gone from memory if you press back.
Right. So hitting back basically means get this person, eliminate this person from the mountain altogether.
Exactly. There you go.
Okay.
Hitting home is different in that it's more of the user telling the system, I'm switching tasks. Right now I'm going to do something else, but I'm not necessarily done. And so when the user hits home, your activity will go from whatever state it's in, let's say it's in resumed, through on pause to paused, and through on stop to stopped. And it'll sit in the stopped state, where it has an instance in memory, but the activity is not visible to the user.
The early days, not too far back, essentially, one common use case that I can think of is I use this application called 1Password, to use my passwords. And anytime I'm logging onto something, essentially what I'll have to do is I'll have to hit home, open up 1Password, copy my password, go back to my previous application. So this is a classic example where it's essentially being if you hit the home button, it's actually going to the pause and the stop state, right?
Yes, exactly. So it'll sit and stopped, and then when you switch back from 1Password to whatever app you were using, it would go from stopped through on start to paused, and then through on resume to running.
Got it. And I mean, that's that's how you do it like an animal. But these days, it's actually much nicer where if you double tap the the square? The recent menu, right? It flips, and this is an amazing feature. I use this all the time, right? It quickly flips to your last used application. Do you know if that also follows the exact same process? I imagine it does, right?
Yeah. I mean, that's what's really one of the things I love about investing the time in understanding how these states correspond to what the user sees and whether or not the instance is in memory, like kind of helps you reason through those scenarios. If you're double tapping and it's switching you to another app, like your activity is no longer visible, but you haven't pressed back or like you swiped away the task. So you have not told the system you're done with the activity, and so it will leave it in stop state.
So basically hitting back means, it's more of like the nuclear option, while hitting home is like sort of like a temporary, I'm not yet sure if I want to get down this mountain kind of
Exactly.
situation.
Yes.
Okay. And what exactly, and maybe you mentioned this, what exactly is the implication in terms of memory? Does that mean if I hit the home button, it's in memory, and if I hit the back button, I've completely destroyed it from memory? So like the application process that you initially mentioned loses, rather like gets rid of the activity if you're hitting back, right? Is that the case also with home?
Well, not necessarily.
It's never that simple, is it?
It's never that simple. When you hit back, yes, like the activity is going to move all the way through all the tear down callbacks to non-existent, where the instance of the activity is removed from memory. It's removed from your app's process.
Perfect.
It's totally gone.
Okay.
Now, when you press home, the activity's instance is going to stay in the app. Your app process's memory until there's memory pressure.
Got it. Yeah.
So if you go off, you press home and then you go watch videos and play Pokemon Go and do whatever else you're doing to consume lots of memory. Ultimately, what can happen is any activity that is in the stop state is considered killable by the system. And so another kind of, so what'll happen, the system will actually kill not just your activity, but your whole app process.
Oh, interesting. So it doesn't just like peel off like layers to like sort of save memory. It's like,
no,
this is like a Boolean thing. It's like do or die kind of situation.
Yes. As of now, and in the documentation, they kind of fuzz around this a bit because I think ultimately one day they want to be able to, be a little less aggressive perhaps and get rid of like activities out of the process, but right now, if your application does not have a visible or foreground activity, it is considered killable, and your process can get killed.
Oh, so even if there's memory pressure, like it isn't necessarily that it's only like the topmost activity that's going to be sort of like conserved back in terms of resources. Like the conservation of resources happens at an app level, is what you're saying.
Right. So it's going to kill off a process at a time. And along with it, it's going to take any of your activities that are in there. So when you're pressing home, you are sitting around in the stopped state, but it is possible that your process could get killed and your activity will go along with it. And this is why, like, you hear a lot of people say, like, oh, rotation, it's such a pain. Like, I'm not going to worry about saved instance state. I'm just going to, lock it so it can't be rotated. Right. And that's all fine and dandy until you get into this, memory pressure situation and your process is killed. So save instance state is also used in this, this situation where your process is killed.
Got it. And again, to be clear, this is if like when they resume back, you want everything to like look and appear as though it's basically as it was before, right? So even though it's gone through the complete life cycle of being destroyed and recreated, you basically want to give, as a nice user experience, you want the user to feel like nothing has changed. And the way you do that was with the save instance state, right? You could be a bad developer and just say, hey, I'm just going to restart all these things until you brought to a starting state.
Right.
But we don't want to do that.
No, we don't. Yeah. I mean, like if users filling in a form or something and they press home to go look up like, I don't know, their address or something, and they come back and it's wiped away all their information, they're not going to be happy.
And if I remember correctly, a lot of the stuff, for example, like as you bring that example up, if I enter something into like an edit text, right? So like a standard Android input widget, if I remember correctly, some of this stuff is already done by the system, right? So like on save instance state already, like the view state is saved without us having to do anything, which is why if it actually gets killed and started again, like somehow magically it still shows up.
Exactly. That's what's happening behind the scenes. It's using the onsaved instance state mechanism to restore it. So to the user, even though the actual like instance of the activity got destroyed and wiped away, to them, when they return back to your application, it appears as if it's the same activity instance because the stash state was used to kind of put it back to the spot they were at.
Got it. That makes sense. And so, as is usually the case, as my mind is like trying to think about ways to break this, So if I overrode the save instance state, right, and I manually didn't call the super on save instance state, I wonder if like that also sort of like prevents this from happening. An exercise for the listener.
Don't do that.
yeah. Oh, do not do this
exercise.
Please do not do this in your production applications. This is not a recommendation. This is just me being, No,
that's great. I mean, that's a lot of how I learn, though, is like asking these questions, being like, these weird what if scenarios, like trying it out. But then also, I mean, one of the many, many things I love about Android is like, I can see the source. So
right.
I can go look at the implementation of, the super implementation of save instance state and see what's going on there and sort of get a better understanding for, what's happening where.
See, you're a much better developer. And so that's like actually the right thing to do rather than just break things.
I do that too.
We said we'll come back to this. So maybe it's time to address the giant elephant in the room, which is activity rotation. Essentially, anytime, and it isn't just necessarily activity rotation, right? So can you walk us through what exactly is happening here? So every time the activity rotates, my activity is killed and recreated. What exactly happens? What process do we go through? Do we, in terms of the life cycle, is it the same thing? Is it different? Help me here. What am I supposed to do?
Sure. So rotating your device, your activity instance goes completely all the way through the teardown cycle. So if it was in the resume state and in the foreground and you rotate, it's going to go back through, on pause, on stop, on destroy to the point where the instance gets wiped from the process. And then it's going to get recreated.
Whoa, so this is the nuclear option.
On create, on start, right, on resume. So it's kind of like pressing back, but then the system, remember, in this case, is the one that's killing the activity. And so it's going to recreate it, and it's going to pass along any saved instance state.
Okay. So
that you've put in place.
Got it. So I mean, essentially the way to think about it is everything's going to start from scratch. So
right.
You really want to make sure you use the callbacks that you mentioned where it's on. Okay.
Yes.
So stepping back, right? If I was designing Android at this point, right? Why would I do something like that? Why wouldn't I just, for example, go to the pause state? For example, when it's partially visible, right? It seems like that would be a better way to go about it, right? Why do you think? Do you know why they would actually go the nuclear route and then destroy the whole thing and then recreate it all the way back? It seems kind of a waste, though. Right?
Well, it all goes back to the device configuration. And so when you rotate the device, that's what's considered a runtime configuration change. The orientation of the device is changing. And so there's lots of different factors that contribute to the current runtime configuration of the device, be it the language, the locale, the orientation, whether or not you're in night mode, all sorts of different things, some of which can't be changed at runtime. I mean, screen density, for instance, can't be changed.
Got it. Okay. Yeah.
Any runtime configuration change results in this complete teardown and rebuilding because that is how Android chooses the resources that best fit the new configuration.
Oh, that makes so much sense. For example, if your locale changes, right?
Right.
That's and if you have different resources for your locale, then really you want the resources to be recreated.
Absolutely. Yes. So the locale, I mean, and you see a lot of that, right, with localization and having different strings and potentially even images, right, for different locales, different languages. That all contributes to the app's, runtime configuration. And so Android is that's its mechanism for picking the right thing.
Got it. That makes so much sense. And actually, now that I think about it, even screen rotation is sort of the same thing, right? Because sometimes, if you want, your layout to be, laid out differently when you're in portrait versus landscape, then it makes sense that all of this would be recreated because there's no chance you're going to be using the previous configuration, right?
Right. Exactly.
So actually the folks who worked on this are really smart because this is actually a really nice and clean, when you think of it in terms of implementation, it's a nice and clean way to handle a multitude of all these different reasons why you would have this configuration or runtime configuration chain. All right, that makes a lot of sense. So the quick question, and I know because listeners are definitely going to ask this question. If I wanted to save up on some of the work that's being done as my activity is recreated, right? We mentioned usually the standard go-to route is like on save instant state, right? Like using that sort of callback. But if supposing I have a requirement where I have this very long network call, right?
Right.
And I execute the network call and I want to keep this thing running and I don't want to necessarily like do all that work again. In your experience, like what are some of the ways that you have encountered that sort of like solves this situation?
Well, I mean, the big thing is if you've got like a long network call and you're like getting a bunch of data that you want to use, you know, in the app later beyond the span of this activity, is to not tie that to the activity's life cycle. I mean, there's lots of different ways you can do that. Maybe you have a background service. Well, I'm curious what your favorite way is. This is one of my questions I like to ask people.
My go-to mechanism is usually using retained fragments. Now, again, I'm not that big a fan of fragments. Like, I'm not a hater, but I'm not a big fan of fragments. But this is one case where I usually love using fragments, and it's for like the retained fragment, right?
Yeah, totally.
The only difference, I guess, with retained fragments is a common sort of like difference that's not brought up, right? Like most folks don't necessarily think about it all the way. Retained fragments help only when you have like this runtime configuration change that we talked about, right? Like only during those cases is the fragment truly retained.
Right.
Like if you straight up like exit your activity and come back to it, like this is not like if you go through like the regular life cycle and, you know, hit back and then exit off, that is like not going to retain your fragments.
Right.
Like, your fragments are going to die then. So this is
exactly
a tricky sort of like thing that folks don't necessarily like immediately always realize, right?
Yeah. And actually I'll have to send you a link. One of my coworkers is writing a really good article right now about using RxJava 2 and some other means to solve this problem. Yeah, it's a pretty neat pattern. But I mean, like I said, the key is once you've got that sort of situation where you're like downloading a bunch of data, it shouldn't be tied to your activity lifecycle. So maybe it gets kicked off when an activity launches, like you kick off a service or something. And you download the data and you, who knows what, store it in a database or cache it, whatever you're doing, but not necessarily tying that to the activity itself. I mean, and if you're doing it outside of the activity, the nice thing is then, like, if you've got, for instance, a background service, then your process will have a service in it. So if the activity gets killed, your process won't necessarily be the first one on the chopping block.
Right. That actually makes a lot of sense because that's something you have to consider, right?
Right.
What if the thing that you just execute again sort of like just dies again because of like the memory pressure, right? So that is good. So the go-to solution, I guess, is like if it's simple enough, use on-save instant state. Otherwise, like as you mentioned, like I think like usually like a good foolproof way of doing it is like maybe using like a background service or something that's not linked directly to the activity sort of lifecycle, right?
Yeah, I mean, there's also things like loaders. So if you're really more specifically concerned about like the configuration change scenario, and you've got data you're like reloading when you first launch your activity, but you don't want it to like reload again when you rotate. I mean, that could be something to consider. So there's different means, but saved instant state definitely, I mean, I think of that more of just for like transient UI state. So something that, you know, like the forms filling in or, you know, scroll position, etc.
Right. That makes perfect sense. And I mean, to be quite honest, usually 99% of the time, I don't necessarily have to worry that much about like my network call, like persisting it across like these different states. It's usually like these common like runtime configuration changes where I usually have to persist data.
Right.
So for those, at least personally for me, like retained fragments work. Otherwise, I just like bite the bullet in, like, you know, to like not worry about complexity. I just like, you know, call that network, make that network call again, right? Now, there are like some unusual situations where you can't afford to do that, but almost always like these solutions sort of work, right? Loaders, actually, yeah, loaders are good. I haven't used loaders in a long time. I'm not that big a fan.
Yeah, me neither. I don't really use them. So.
But you're totally right. Like that's actually a very legit way of handling this problem. All right. So, okay. Wow. This is super informative. I feel like I've actually learned a whole bunch of stuff. But before we go, because I know this is like one thing that came up, right? we've understood, like, I think at this point, like, we've very clearly understood, like, the nuances, like, for activities. What happens in Fragment? Like, does Fragment have, like, a new story? Should we wait for, like, Kristin's 2.0, like, Fragment Lifecycle, the new presentation that comes out?
I'm looking for next talk, so maybe.
Well, definitely. And if you do, like, we'll make sure to, like, have another episode where we talk about it, right?
Awesome.
All right, Kristin. So one last question. So I do know with the instant apps coming, like, do you know if, like, anything's, like, necessarily changed with all of this? Because I do know, like, it's, like, a very different sort of concept, right?
Yeah, I mean, I honestly don't have any experience with instant apps, and I just applied for early access developer or early access to it, believe it or not. So hopefully I will learn about it. But I don't know. Do you?
Yeah, I didn't even know about basic activities. You can't expect me to know about instant apps.
You did.
All right. So, Kristin, thank you so much. I'll make sure to add, like, a link to your talk as well, because again, your talk, you've done a fantastic job, and even, like, the different resources, like, I'll point to, like, specific slides that we talked about.
Okay, great. So I really appreciate you letting me talk about this with you for a while, because I really enjoy it.
It has been an absolute pleasure. Thank you so much. But if folks want to reach out to you, because if they have more questions,
sure.
What's usually the best way for folks to sort of, like, reach out to you?
I mean, they can hit me up on Twitter. I'm at Kristin Mars. So if you want to put a link to that,
Absolutely.
You can find me at Big Nerd Ranch. So I teach our week-long boot camp. You can come spend a whole week with me if you want. We can talk about activities and fragments and all other sorts of good stuff. Even better.
Right? Yeah.
You can check out our Android programming book. The 3rd edition actually just came out last month, believe it or not. So there's some good stuff in there.
Wow.
But yeah, I think reaching out to me on Twitter, I'm pretty active there lately. Come and see me in class.
Fantastic. Thank you so much. This has been amazing. Once again, we want to thank Rollbar for sponsoring today's show. With Rollbar, you can catch code errors even before your users do. Remember, they support a gazillion platforms and have support for some really cool, nifty integrations. We have a special offer for Fragmented listeners. Go to rollbar.com/fragmented, sign up and get their Bootstrap plan for free. Thanks again for supporting today's show, Rollbar. That's it for the show, folks. Fragmented is hosted by DonnFelker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.